So we have talked about rational expressions or algebraic fractions. Talked about what they are. We talked about how to state non-permissible values for them. We talked about how to reduce them and how to multiply and divide them. So the next step is going to be, how do we add and subtract these? Well, very similar to numerical fractions. You can add and subtract fractions as long as they have the same denominator. Okay? But with rational expressions or algebraic fractions, it can be a little bit more challenging to figure out what the lowest common denominator is. But you'll get it. So remember, the lowest common denominator of a set of numbers, okay, or the lowest common denominator of fractions, that's the smallest number that all the denominators divide into. So if I had fractions that had denominators of 4 and 6, what would be the lowest common denominator? 12. Okay. If I had a lowest common denominator of 3 and 8, sorry, if I had denominators of 3 and 8, what would be the lowest common denominator? 16. 24. 3 doesn't go into 16. Okay. So how do we do this when it involves variables? So let's take a look at an example. Let's say we've got two algebraic fractions, two rational expressions, and the denominators are 2pq and 3pr. Okay? I need to figure out what the lowest common denominator of those two is. So what I do first is I look at the numbers. What is the lowest common denominator of 2 and 3? It's 6. So I know that the number part of my LCD has to be 6. If I look at the first denominator, not only does it have to have a 6 in it, but it must have a p and q in it for this to go into it. So right now, my lowest common denominator, if it is the final answer, is 6pq. Okay, 2 and 3 go into it, p and q go into it, but then when you look at your second denominator, right, there's a p in the second denominator, but I don't need to write it again because it's already here. But this is not. So it has to be part of the LCD. So 6pqr is going to be the correct LCD. So it's the LCD of the numbers, the coefficients, and then all the variables that you see. And you don't have to repeat variables. So let's take this one. X squared y and xy squared. What do you think? X squared, y squared is correct. Okay, because, well, I know it has to have an x squared in it because of the first denominator. I've already got two x's into it, like two x's being multiplied into it, so I don't have to put another one. Y squared is the most number of y's that I see, but I don't have to put y cubed because y squared is enough. So x squared, y squared. What about if we get those factored forms for the denominators? Easiest way to do it is just multiply them together or show them by multiplication. Don't multiply them through, but show them by multiplication. So if I've got this and this, the LCD is simply this times this. That's it. You can always find a common denominator by just multiplying all the denominators. So when we've got like binomials like that, just put them together by multiplication. Don't multiply them through. So now that we have an idea of how to find the lowest common denominator that involve variables and that involve binomials like this, we can start looking at adding and subtracting these rational expressions. We're not going to worry about stating non-permissible values for these. Okay? We've already practiced that. We're going to focus on the adding and subtracting. So here, basically, these are the two rules for adding and subtracting. If you've got two fractions that have the same denominator, to add them together, you just add the numerators and put it over the same denominator. Same idea with subtraction. So let's look at some examples. And we'll start with no variables in the denominator. What's the lowest common denominator of this? 12. So here's how we set it up. We're going to make a single fraction over the LCD we just found. What must I multiply the top and bottom of the first fraction by to get to 12? What do I have to multiply 4 by to get to 12? 3. Doesn't that mean I have to multiply the top by 3 as well? So I've got to do 3 times 3x. Subtract. What do I multiply the second one by? 2. So let's simplify the top. 3 times 3x is 9x, minus 2 times 7x, which is minus 14x over 12. 9x minus 14x is negative 5x over 12. And just like numerical fractions, always look to reduce. We can't reduce this. So we're done. So notice we're doing it a slightly different way. We're making it into a single fraction right to begin with. Whenever you see more than one term in a numerator or denominator, think parentheses. That's important. Well, what's the lowest common denominator of x minus 4 and x minus 4? Don't overthink. X minus 4. They have the same denominators. So that means I can add the numerators. That means I can just do 8 plus 3 up top and keep my denominator of x minus 4, and I get 11 over x minus 4. Hmm?
But if it wasn't 2x minus 4,
We'll see that in a second. We'll get to that. This one, again, whenever I see two terms, they've got to stay together. What keeps them together? Parentheses. Well, what's the lowest common denominator? N. It's already, they're both the same denominator. So, and you got to be careful with this. This is why the parentheses are important. We're going to take the first numerator minus the second numerator, which is in parentheses. That makes a difference. Because when I take out the parentheses, it's subtract m, subtract 1. Well, the m minus m disappears. So we're left with negative 1 over n. The next one, we're going to have to do a little work now to find the LCD. What's the lowest common denominator? X squared. X is not enough because there's two x's being multiplied by each other here. I need x squared. So now I make a single fraction with my LCD. What do I have to multiply the first fraction by to get from x to x squared? What do I multiply x? Just x, right? So doesn't that mean I have to multiply the top by x? So 4 times x, or 4x. The second fraction already is over x squared, so I don't have to multiply by anything. I just leave it as plus 6. Can't combine them, can't reduce. That's as far as I can go. Remember, you see binomials. Think parentheses. So here's an example that you were asking about, McKenna. What's the lowest common denominator of this one? No, don't multiply it through. You just have to show the LCD is going to be when I multiply these two. You don't have to multiply it through. Don't. It'll make it more complicated. Okay, so yeah, hang on. So our lowest common denominator is x plus 3 times x minus 2. What must I multiply the 4 by? But there's already an x plus 3 here. X minus 2, right? What's in here that's missing here? An x minus 2, right? So that's what I have to multiply this one by. And then subtract 5. Well, what's in the LCD that's missing in this denominator? X plus 3. So we get that. Now we want to simplify the top as much as possible. But remember, leave the bottom. Leave it in factored form. Leave it as a multiplication. Because if we need to reduce, we'd have to factor them anyway. But let's simplify the top. 4 times x minus 2. Hello? 4x minus 8. And then negative 5x plus 15 minus 15. Collect the x's to make negative x. Collect the numbers to make negative 23. Keep the denominator in factored form. Do not multiply through. There's nothing common up top and on the bottom to cancel out, to reduce. So I'm done. I see more than one term. What's different about these denominators? When you see it, these denominators, what do you think you're going to have to do? Factor, right? Okay. So we always want to factor, and then we can find the LCD from there. So before we even both of these are trinomials. x, 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 x. Two numbers that add to 5 multiply to 6.
Oh, wait. Well, that's negative.
Multiply to 6 and add to 5.
6 and then.
Oh, you guys, you're making it way too complicated. 2 and 3.
Oh, okay.
Remember, this is a 1. Two numbers that multiply to negative 2, but add to positive 1. Negative 2 and 1 add to get negative 1. Negative 2 and 1 add to get negative 1.
Negative 1 and 2.
Negative 1 and 2 work. Now we got to get the LCD. So we've got all factor denominators. So what we do is we write all the factors that are different. Well, look at the first one. In our LCD, we need x plus 2 times x plus 3. But looking at our second fraction, we also need x minus 1. But we don't need x plus 2 in the second fraction because we already got it from the first. So our LCD is 3 binomials. So that means they look complicated. There's lots of numbers, lots of x, lots of operation symbols. But no, it's not. So what do I have to multiply the first numerator by? What's in here that's missing here? X minus 1. That's what I got to multiply this one by. Plus the second numerator, what do I have to multiply this one by? X plus 3. So we get 2x minus 2 plus 3x plus 9 all over that big denominator. And then we can simplify up top and get 5x plus 7 over that big denominator that, of course, we are not going to multiply through because that's just crazy. Wouldn't make him do that much work. No, I'd like to do a couple more, but we're not going to do the bottom half of the next page. You can cross it out. Okay, like ever. No, the bottom half. So sassy. I said, I'm so sassy. I said, I'm so sassy.
I'm sure you just said so.
Wow, somebody's looking for a fight. Somebody's a little, got some anger issues, a little snippy today.
She just said, you said so. You said
I love how somebody tries to enter a conversation that just you and I are having. We'll just ignore them. Yeah. Their first name begins with Turkey and their last name is Pickle. What's up there, Turkey Pickle? I make them up all the time.
No, you don't.
I'll have another one. I got turkey biscuit. I got beef turkey. I got turkey cheese. I got turkey pickle. I'll keep going. I got another year.
I like turkey cheese.
Okay.
What about turkey?
All right. Next one.
Don't say turkey, but.
Okay. So this next one, I am going to have to factor the second denominator. Don't have to do anything.
You're writing and it's really annoying because I have to.
Sit in a different spot.
No, because my friends say. Just right on the other side.
Well, we're swimming.
You're so sassy, Kira. You're so sassy. How do I factor the second one?
We factor it.
Yes, we do. We got y and y. We want two numbers that multiply to -2, but add to +1.
-2?
No.
No.
2 is negative.
No.
2 and -1.
That's literally what I just said.
You had -2.
What's our LCD? What's our LCD?
Y minus 1 and y plus 2.
I don't need to write the y minus 1 again, because I've already got it. So now, and again, don't forget, whoops, we can write a single fraction. Okay, so we've got y minus 1 times y plus 2. Notice the first denominator is y plus 1. What must I multiply the first denominator by to get this? Y plus 2. Notice that's a binomial times a binomial. That's 4 multiplications. Minus, what do I have to multiply the second one by? Nothing. It's the same.
No.
But
Yeah.
remember, there's still parentheses there.
Yes.
Without the parentheses? Absolutely, because they need it.
You don't have that here yet.
Well, maybe not that severe.
Maybe though.
Okay, what is y plus 1 times y plus 2?
Y squared plus 2.
Okay, so if we did the 4 multiplications, hang on. If we did the 4 multiplications and added the 2 in the middle, that's what we get as the final answer. Because this is y squared plus 2y plus 1y, which is 3y. And then we've got minus y. What comes after that?
Plus 1.
Plus 1.
Negative, negative.
Oh my.
Pardon?
Yeah, I did.
Okay,
I told them I'm not. It's actually.
what do I get when I simplify everything? Up top,
Y squared
y squared
plus 2y
plus 2y
plus 3.
plus 3 over that common denominator. Now, remember, reducing, we need to factor.
Yeah.
When you reduce, you got to factor the numerator and denominator if you can. Well, hang on. Can you factor the numerator? It looks like a trinomial.
You can.
It looks like y and y, and it looks like two numbers that multiply to 3 and add to 2.
Bottom. Oh, we have to do it.
No, we're doing the top.
Multiply 3. That equals -3.
Those multiply to -3.
See, I don't like 3. 2, no, 3. Yeah, it's 2 times 1.
2 times 1 is not 3.
It's only 3 and 1.
You're having trouble, aren't you?
Yes.
Yeah, you can't do it. There is none.
Or,
There's nothing that multiplies to 3 and adds to 2. It's close, but it's not. It won't work. So that's as far as we can go. Okay, but you got to look for that. You got to look for potential factoring to reduce.
Hey, how many more tests do we have?
Let's focus here.
Here, 10.
All right, what am I going to do first? What am I going to do first?
You're going to factor.
I need to factor the denominators.
Yeah, you do.
Both of them are x squared trinomials.
I like them.
That's good.
There's a little detail here.
What do we got for the first one, first denominator?
Add to -5, 3. No. 5.
Always think,
5 and 1 is giving.
Yes. -6 plus
yes, -2,
Oh,
-3.
what?
Well, because both of them add to a negative and they have to multiply to a positive. There's no other one
I think she's 6 and -1.
6 minus 1 is
because they multiply to -6.
and they add to positive.
What about the second one?
2.
Again, they're going to be both negatives. I can tell because the sum's negative, the product's positive.
3 and 4.
-4, -3. What's our LCD?
X minus 2, X minus 3, and X minus 4.
Maybe what's dinner?
Okay, so now I've got to make my single fraction. I've got x plus 3.
Can we slow down just a little tad bit?
What must I multiply the first numerator, x plus 3?
Minus 4.
And that's 2 multiplications. Because it's a binomial times a binomial. Plus the 6, what must I multiply the 6 by? X minus 2.
Holy smokes, I haven't even finished writing the bottom ones.
Maybe instead of commenting, just write.
Didn't. Oh, yeah, well, I'm on YouTube.
Okay, what is x plus 3 times x minus 4?
X squared. You know, minus 12. Minus 7.
Minus x
Wait, where are we?
minus 12. Because you did the 2, yeah. What's 6 times x minus 2?
6x minus 12.
Okay. All over this.
Over.
So now we've got to simplify the top by collecting like terms.
We have x squared.
X squared plus 5x minus 24. A potential factoring one.
Yeah.
A potential factoring one.
Let me think. It's not giving back. I'll send you that.
Yeah, I'll give you a hint. You can.
Well,
Plus 8. Correct.
When she's a genius.
See anything?
X minus 3. Yeah.
Yes, I'm so proud of you.
So we are left with x plus 8 over x minus 2 times x minus 4. You don't need the parentheses in the numerator when there's only a binomial up there. Yeah, that's the big one.
I feel like that's a easy thing.
Okay, that's the big one. Lots of variables, lots of numbers, lots of fractions, lots of symbols. Okay, but if you keep track of everything, you can do these. So what I would like you to do for next Monday, because that's the next time I see you.
Thanks.
Don't be like that.
Well,
That's not very nice.
I didn't mean that. I meant like that on
All of exercise 5.3, but don't do 2I and J. Take out 2, hang on, take out 2I and J.
2I and J.
Yeah, those are the fractions that look like this. We're not going to do those. We're not going to worry about those. So you can take those out. Yes.